Okay, so we're going to take a look at one more type of example today. That is dividing radicals. So for example, if I have the square root of 36 over the square root of 25, well really we can just evaluate each of those separately. So the square root of 36 is 6, the square root of 25 is 5. Now, something important to realize is that that would be the exact same answer if I had it written this way. Because when we write a radical over a fraction, we can actually just change that problem back and forth between a radical over the whole problem and a radical over each side of the fraction. So for example, sometimes we'll have the square root of 144 over 25, and we'll want to take that and say, okay, the square root of 144 over the square root of 25, we'll say that that's 12 over 5. But other times, we'll have the square root of 36 over the square root of 3, and we'll want to take that and make it the square root of 36 over 3, which is the square root of 12, which is 2 square roots of 3. So if we can reduce the numerator and the denominator, we may want to write it as a radical over the whole fraction, and if we cannot, we may want to write it as two separate radicals. Now, sometimes we have a denominator that ends up remaining a radical. Well, we actually learned earlier this year that we should never have a radical in our denominator. We should always rationalize our denominator. Well, we can rationalize it by making our denominator into a perfect square in this case. So the square root of 2 is not a perfect square, but if I multiply it by another square root of 2, now I'm going to get the square root of 4 in my denominator, and the square root of 4 is just 2. So that's now an appropriate answer because my denominator is not in a radical. I'll try another one like that. The square root of 16 over 5. That's the square root of 16 over the square root of 5, which is 4 over the square root of 5. I cannot have that denominator as a radical, so I'm going to multiply by the square root of 5 to turn it into a 25. So now I have 4 square roots of 5 over the square root of 25, which is 4 square roots of 5 over 5. Do two more examples. Square root of 12 over the square root of 5. Okay. I can take my numerator and reduce it to this 2 square roots of 3 over the square root of 5. I've got to multiply both sides of my fraction again. So I get 2 square roots of 15. Remember, we're going to multiply the radicands together over, and some of us may be concluding right away, this is the square root of 25, which is just 5. We may not even have to write the step of square root of 25 in the denominator. One last problem. If I do the cube root of 3 over 2, that's the same as the cube root of 3 over the cube root of 2. And now this is a little different. I can't multiply by the cube root of 2 because that's going to make my denominator a 4. 4 is not a perfect cube. But 8 is a perfect cube. So if I multiply both sides of my fraction by the cube root of 4, that's going to turn my denominator into the cube root of 8, and that is a perfect cube, and that makes it not inside a radical. That makes it a 2.